Hello, this is Dr. Michael Hassan, the Engineering Doctor, and this is lecture number 48, Ring Counter and Jansen Counter of Chapter 7, Counters and Registers of the course Digital Logic Design or Digital Systems or Digital Electronics. This is the disclaimer for you to read. I cite 3 references in Digital Logic Design, however, there are many books available on the subject. Today, as we said, we will talk about ring counter, also known as cyclic or circular shift register, Jansen counter, also known as a twisted ring counter, and we'll cover modular integrated circuit registers. The ring counter, the serial data outline of a serial in serial out shift register is connected to the serial data in line as shown. So here we have 4 flip-flop shift register, and the data in this case will shift from the left to the right. I will take a Q0 and feed it back to D3. Such a circular or cyclic shift register forms a ring counter. The content of the shift register is shifted 1 position to the right upon the occurrence of each clock pulse. So if the initial data is 1100 after every clock cycle, you will see 0110, 0011, 1001, then 1100, and the cycle will continue. Now, if you clear this register, and you will load all zeros, if you activate the clear pin, you will load all zeros to the shift register, and it will remain so, unless actually you upload another data, because all zero will go, and this is really the drawback of the ring counter. The ring counter will circulate the data, whatever the data is. So if the data, all zeros will remain in the shift register, regardless how many clock pulses you will apply. Now the Jansen counter, the twisted ring counter, Jansen counter, Q0 prime is fed up to D3. And the beauty of this, always you will find data, and this is what in the register. So if you started feedback into the serial input shifter, if the initial data is 0000, then after the first cycle, or after each clock cycle, you'll find 1000, 1100, 1110, 1111, 0111, 0011, 001, then 000, then the cycle repeats itself again. So this is the Jansen counter. And you can find a lot of applications to circuit like this, like Christmas tree decorations, and so on and so forth. Now, modular registers. The most popular MSI modular register are the 7491A, which is an 8-bit serial in serial out shift register. We have another modular shift register, which is 7496, is 5-bit serial in serial out, serial in parallel out shift register with asynchronous preset and clear and common clear. The 74164 is an 8-bit serial in serial out and serial in parallel out shift register with common clear. The 74165 is an 8-bit serial in serial out parallel and serial out shift register with asynchronous parallel load and clock inhibit, which is clocking is accomplished through 2-input OR gate, where 1 input is the clock and the second input is the clock inhibit function. The 74174 is a 4-bit parallel in parallel out registered with a tri-state output on common clear. The 74174 is a 6-bit parallel in parallel out registered with common clear. The 74175 is 4-bit parallel in parallel out registered with common clear. The 74178 is a 4-bit serial in serial out parallel in serial out, serial in parallel out unidirectional shift registered with common clear. The 74176 is a 4-bit serial in serial out parallel out unidirectional shift register with asynchronous poll load and asynchronous data hold. The 74194 is a 4-bit bidirectional universal shift register with synchronous load, common clear, and clock inhibit. The 74295B is a 4-bit shift register, shift right shift register with a tri-state output and synchronous poll. The 74299 is an 8-bit universal bidirectional shift register. The 74374 is an 8-bit poll and pull out register using D latches instead of edge-triggered flip-flops. The 74374 is an 8-bit poll and pull out register with tri-state outputs. The 74377 is an 8-bit poll and pull out register. The 74378 is a 6-bit poll and pull out register. The 74379 is a 4-bit pull and pull out register. And you see, those are really the most popular shift registers available on the market. So if you need any shift register, you can build your own using discrete components or the flip-flops and gates or multiplexers. And we have designed every possible shift registers in these lectures. So, and this would be the end of this lecture as well. I would like to thank you so much for listening. And please subscribe by clicking on the blue circle. Sincerely, Dr. Hassan.